Current in an AC circuit is given by I equals to 3 sin omega t plus 4 cos omega t. Then, okay, first let's write down the proper function for the current, instantaneous current. This can be written as 5 times of 3 by 5 sin of omega t plus 4 by 5 cos of omega t, which is 5 times of cos theta into sin omega t plus sin theta into cos omega t. This can be assumed because here I have assumed cos theta is equal to 3 by 5 and sin theta equals to 4 by 5. This is valid because first thing sin square theta plus cos square theta is 1 and each of them is less than 1. Right? So this can also be written as 5 times of sin of omega t plus theta. This is the instantaneous current. So you can see that the amplitude of the current is 5 amperes and RMS would be I amplitude by root 2, that is 5 by root 2. So option A is wrong. Mean value of this current in 1/2 period will be 6 by pi. That is I average. I average is given by 2 times of I peak by pi. That is 2 times. I peak is 5 by pi, which is 10 by pi, but given is 6 by pi, so B is wrong. Now, if the voltage is Vm sin of omega t, then the circuit must be containing resistance and capacitance. Let's analyze that. If voltage is Vm sin of omega t, we can see that the current is leading the voltage by theta angle. In what kind of circuit the current leads the voltage? Only in case of capacitor circuit. So either it cannot be a pure capacitance because theta is not 90 degrees. So it should be a resistor with a capacitor. So most probable option is option C, where it has both resistance as well as capacitance.